Okay, welcome everyone. Very happy to host this event about Avail. And with me, we have Anurag, which is co-founder of Avail, and we have Apoorv, who is the founder of Karnot. So we'll discuss about data availability, about Avail solutions specifically, about the collaborations we are doing between StarkWare and Avail, and also between Avail and Karnot, and the role of Madara in the StarkNet app chain landscape, and why data availability is an important topic. So yeah, thank you guys for being there. So yeah, I will let you start by introducing yourself quickly, and then we can jump into the topics. Yeah.
Yep. Yeah, thanks Abdel for inviting me here. So just to give you a background, Anurag, co-founder of Avail. Before this, I entered the crypto space in 2017. I co-founded Polygon at the time and built a lot of the Polygon POS stack, amongst other things. Crafted a lot of the ZK strategy as well. Avail, actually we started within Polygon back in 2020, and we spun Avail out of Polygon last year in March. And so Avail is now a separate project entity in itself. And so this Avail focuses on all the problems that the rollup centric future brings to blockchain. And so the first problem that we really solve with Avail is scalable data availability, because the rollups are very hungry for data availability. We have other plans which we can get into later, but so that's a brief introduction.
Thank you. And we have Apoorv. Yeah.
Thank you for having me over here. So hey everyone, yeah, I'm Apoorv. I got into the StarkNet ecosystem like approximately 1 year ago. I think like last year, this time I was in Israel for the Hacker House, which was obviously amazing. And from there, I started like Madara started. So for people who don't know, Madara is basically like a framework for you to build your app chains using the same technology which has been powering like DYDS, StarkNet, and so on. So it started as a project by the exploration team, where Abdel and the team started it off. So I started contributing there. From there, one thing led to another. I started working with Pragma, which is an Oracle solution, who's also building an app chain with Madara. And then finally, I founded Karnot, which is a roll-up as a service solution around Madara. So we basically help you launch, manage your infra if you're launching a Madara chain. So yeah, that's a pretty much short intro.
Thank you very much. I have a first question for you, Anurag, which is about when you spun out from Polygon, and how hard was it? And also, do you still have people who make the confusion between Avail and Polygon? Because I see time to time on Twitter people referring to Avail as Polygon Avail and so on. So I'm just curious, how hard is it to detach from the branding of Polygon?
Yeah. No, I think that's something that has stuck with us. Like, we were, of course, initially known as Polygon Avail, and even though we have spun out, some people still refer to us as Polygon Avail, even though Avail is a separate entity right now. I think like one of the reasons among many was that Avail is a solution that kind of tries to solve a lot of the problems that a roll-up centric future of Ethereum brings, right? Like, so as I said, right, roll-ups are pretty hungry for data availability. And so when we were at Polygon, people perceived us to be a very Polygon roll-up specific solution, but roll-ups are not only something that Polygon builds, right? Like, we have a wide variety of high quality teams building roll-ups, and the truth is that there are going to be roll-ups of different kinds, right? Like, it's going to be not only the EVM roll-ups, it's going to be very different ones, such as the Cairo from StarkWare, for example, but also other execution environments, right? And that is required because the roll-up is a very neat construct, right? It allows you to experiment on layer 2, so to speak, right? Because you cannot by nature do too much experimentation on the base layer, right? So we wanted to kind of appeal to roll-ups across the ecosystem, not only polygons rollups, for example. And so that was one core reason of like spinning out, so that we are a credibly neutral player who can like work with all rollup ecosystems in general to grow the entire rollup ecosystem. So of course the move was there. Of course it's not that easy to shake off the Polygon brand, but like we are like moving ahead, and slowly that will people will know as Avail, not only as Polygon Avail.
Yeah. So can we say that you will succeed once people completely forgot that initially you started from Polygon? This will be the sign that Avail is successful project by its own. Okay, yeah, sounds good. Amazing. So I think it's important for the next topics that we define the concept of data availability, because it's a word that is used everywhere, but I think that there is a lot of confusion about this concept, and also I think retrospectively that the naming was not necessarily helping users actually. So who wants to define what is data availability first, and why it's important, especially as you said, Anurag, given the Ethereum rollup centric roadmap, and what is the role of data availability in that? Yeah.
No, I think that's an extremely valid question. Like the term data availability is very misleading. Like it can mean a lot of things. Some people also confuse data availability with data storage, for example. So some people have tried to rename this as data publishing, for example, which again is also slightly problematic. Some people kind of confuse it with like long-term data storage as well. So then there are various other things that people want to kind of call it. Like I've heard bulletin board as well, for example, which is actually the more accurate, technically more accurate term actually. But essentially, like data availability is not really something new. Data availability has always been a core feature of blockchains. Like every blockchain has the data availability construct, right? Like even Ethereum has a data availability by default. Any POS chain, any blockchain by general has data availability by default, right? Like the reason why data availability as a separate layer has gained more credence over the years is because primarily I will say because of the rise of rollups in general, right? Like so, and the demarcation of blockchain functionalities into different layers. So like in general, if you kind of think of it, right? Like so there's data availability, there's execution, and then there is like consensus or finality elements to the blockchain. And as Ethereum came up with the like a more modular architecture, right? Like in the sense that Ethereum began life as a very execution focused layer, but then from a execution scaling perspective, like rollups were invented. Actually, I came into the space when we started building something called Plasma, which is out of favor at the moment because it doesn't work. so that was one of the earlier scaling solutions. But yeah, essentially, like this whole demarcation of layers has put the focus on data availability a lot, because if you want to do a lot of rollups on top of like an underlying base layer, you need to optimize the base layer for data availability. And data availability in general, like to put it in a like more simplified manner, it's actually, you can think of it as transaction order verification, right? Like so there is this rollup blockchain, which is a separate blockchain actually, which kind of submits the transaction order, or either it is the transaction order or it is like state diffs data, for example, but it puts like a commitment to this data on the base layer, and to have so essentially it is an order to which the rollup has committed to. So again, not getting into a lot of gory details, but like if you have like a rollup with a sequencer which is accepting transactions, the transactions are not considered final only if it is accepted by sequencer. They have to commit to the base layer, and the base layer gives the cryptoeconomic guarantee that the transaction order or the state diffs order in which was sent by the sequencer entity, for example, that will not be reverted back, right? Like, so that's the transaction order guarantee that you get, let's say, from posting like commitments to, let's say, Ethereum, for example, or Avail, for example, right? Like, so you can think of this as more as the transaction order verification of sorts. Like, some data has to be committed by this off-chain execution unit to the base layer, by which actually you kind of remove the trust assumptions of the sequencer, right? Like, so for example, once the sequencer has committed to the data availability layer, and the data availability layer has finalized that, then the sequencer should not be able to kind of revert that order back, right? Like, so then that's why you can have like single sequencers, like securing multiple million or $1 billion of value, because you don't trust the sequencer, you trust the transaction order verification, and of course the execution proof aggregation that is also submitted back to the base layer. So now, I mean, I think I put out a very long intro, but getting to the what is the data availability thing, right? Like, so essentially why this has become important is that we've now come up with this more efficient way of verification, and thereby scaling of this separate DA layer, right? Like, and this is called data availability sampling, and that's why the whole data availability space is kind of in being talked about. Is that conventionally data availability is there on each blockchain, but the verification mechanism was by way of a full node or by downloading all the transactions. What we came up with was this technique of data availability sampling or data availability sampling light clients, by which you can kind of scale the data availability block space on the base layer. But because we have this data availability sampling, it can be even cheaply verified, right? Like, so that's how we kind of scale the base layer in terms of data availability. And this is sort of the same direction that Ethereum is taking in its dank sharding roadmap, and like what Avail and other blockchains also do in terms of DA specific constructions. I just stop not to hog so much time.
Thank you for this great introduction about the role of data availability. I think it was very helpful. I think I would add maybe something to help to have the intuition also about why it's important, because you want basically to be able to reconstruct the state of the rollup, even if the operator has lost the data in a catastrophic event where especially in the context right now where all layer 2s are centralized, you don't want to trust that the operator will keep the data and so on. So with the data availability, you want to give enough time to a sufficient number of honest participants to be able to watch the data and reconstruct the state if needed. And also, I think that sometimes it's important also to say that you need some mechanism to check that something will be done if the data are not available, because as you said, it breaks the trust assumption on the sequencer, but only if you have your full nodes on the layer 2 that are capable of detecting that the data are not published on the base layer and whatnot. So I think that's important. Also, you mentioned an interesting distinction between the different mode of rollups when they submit data. Some of them submit the compressed transactions, and some of them submit the state diff. So maybe Apoorv, you want to tackle that and explain the differences between that and who is doing what in the landscape?
Yeah. So like before that, actually, I just wanted to add on one thing over there. Like,
please.
Obviously, like from the app chain point of view, I think like obviously like what Abdel mentioned is, it's for reconstructing the state so that you don't want to like trust one centralized party. And I think one interesting part about like the data availability thing is that it's compared to a lot of solutions that we build in crypto, where like people try to solve the problem before it actually occurred. DA, because like when we speak to app chains, like DA is one thing where like people were actually experiencing the problem where app chains were paying an insane amount of fees on the base layer to post their data. And now when we talk to app chains, like people have actually started considering where like why not just post your DA to alternate layers, because it's just cheaper. And it's just cheaper, and it's available right now because like changing Ethereum is like first we have product sharding, then we get 4844, which is obviously the good track to be on. But because Ethereum is like so big and securing billions of dollars, we know it's going to take time. So solutions that I want to launch right now, and especially if you know like if you think of these like I like to think of app chains in general as like startups. And when you're building any startup, you want to save on money, right? So maybe like posting on an alternate DLN might not be the best solution if your customers are like big banks and institutions who want like the topmost level of security right now. But like depending on that's also like arguable. But yeah, depending on which sector do you fall in as an app chain, right? Maybe you're building a game, maybe you're building something that that is okay to be a Validium or even like a sovereign rollup, which we can like go on maybe in later discussions. DA is like an amazing solution for new app chains to like start out comfortably. You don't need thousands of dollars to just start out. And like this is the app chain perspective. Obviously, Anurag gave the technical point, but yeah, like coming to the other part of state days versus transactions, like Abdel just mentioned. Yeah, so basically the difference essentially is that some types of rollups. So the first is like optimistic or ZK. So optimistic rollups only have they only post transactions. They cannot post status. The simple being because you cannot have fraud proofs if you are posting status with optimistic rollups. It's arguable like how many of them have fraud proofs, but yeah, you cannot have fraud proofs if you're just doing statements with optimistic rollups. So that's completely out of the question. With optimistic, you like take all the transactions and post them on the L1. When you come to ZK rollups, then you have two options, right? You can just post your transaction data, which is I think what Polygon, ZK VM, and Scroll do, or you can like post state def. So what state def essentially means is that you don't need to post all your transactions. You can just post the difference in state. So like if there's like two parties, like let's suppose me and Abdel, we are doing billions of trades with each other. We just post the initial state and then we post the final state that Apoorv has this much balance, Abdel has this much balance. So you technically save a lot of costs because you're not posting the million transactions we did. We just posted the end state. So that's a little different over there. So I think that's maybe Anurag can talk about that part, because since we're not posting transactions and we're posting state defs, we're technically not committing on a specific order. Also, it's also true that we cannot like change the, as long as like you have a full node that verifies that this status is for these transactions, that the order is technically committed, because we cannot create a different proof. So that's one difference, but I think it sort of achieves the purpose as long as your prover cannot be like changed, like as long as you're like you can't like change your proving logic or something altogether and just game the system.
Yeah.
Yeah, I think just one additional point I want to add here is that in general, like if we think about like ZK rollups in particular, right? Like so there are two aspects to generally when you think about like security, for example, right? Like so there's a liveness guarantee and then there's a safety guarantee. In ZK rollups specifically, right? Like because we use ZK proofs, ZK execution proofs, right? Like so the safety element is actually is a mathematical guarantee given the proving system used, right? Like as long as the proving system is valid, for example, the prover that post proofs, right? Like that guarantees the execution correctness. So in general, actually. Before ZK's proofs were starting to get actively used, right? Like so there was this whole element of because like I said previously, like I started with like my career in crypto with off-chain plasma, which had off-chain data availability and off-chain execution. And so a lot of the assumptions were like the security assumptions in those systems was pretty like it was tenuous, like so we had to do a lot of workarounds to kind of implement something. What ZK has brought to the picture is that like you can actually build efficient state machines that are now ZK proof, and you don't have to worry about execution correctness. And so even if you have, let's say, I don't know, like 100 billion or whatever high amount of value in a rollup, right? Like there's no way that like the operator can like steal funds, for example, right? Like I mean, even if the data is not available, just to put in perspective, of course funds, there might be a liveness constraint, like if let's say the data is not available for whatever reasons, right? Like, and of course there are like the design decisions that we took with Avail was we wanted this to be very decentralized setup, right? Like, so that's why we chose substrate, which like actually Madara also uses, because we are able to now get grandpa and babe consensus, which is basically which is now able to support 1,000 validators with a very extremely good hybrid ledger. So there's a finality gadget on top of the block production. So anyways, basically what I'm trying to say is that the kind of way in which we view security for ZK rollups or ZK validiums, for example, has to be kind of in the way that reflects the security guarantees, right? Like, because ZK solve a lot of the execution correctness guarantee. Now, from a Ethereum perspective, right? Like, if you want to take Ethereum assets of Ethereum into a ZK rollup, their Ethereum DA is by far the best solution, like in general, right? Like, because you want to be able to exit these Ethereum assets off the bridge, for example. But when we are talking about native assets, for example, right, like native assets that are minted on the rollup, like that are not native Ethereum assets, right? Like, they don't share this guarantee because these are not logged on the bridge contract per se, for example, right? Like, so there's a lot of distinctions in this whole design space, which we are kind of now uncovering, for example. So yeah, just wanted to put across that point.
Thank you very much. So I wanted to talk and ask about the choice of substrate. So you started to talk about that. So let's discuss a bit about this. And I'm curious to know what were the options on the table back in the days when you chose substrate. And we also chose substrate for Madara. And I will let also Apoorv talk about the experience after using substrate. So you mentioned that decentralization was one of the reasons. But can you explain more, Anurag, on the reasons about why choosing substrate?
Yeah. No, for sure. So I think we were, in 2020 when we were starting Avail, right? We are thinking of what node frameworks to base our the validator node for Avail on, and the main two choices at that time were Tendermint and Substrate. Tendermint is also a great framework. We actually used Tendermint in the Polygon POS stack. Like, people who are not aware, we have actually two nodes in the Polygon POS stack. So there is this Tendermint layer, which handles things like validator selection and such. And then there is a faster block production layer called Bohr. So there's something called Heimdall and Bohr, and Heimdall is built on Tendermint. So we had like a lot of experience working with Tendermint back then. So for sure, like Tendermint was a great framework, but Substrate was, like at that time was also becoming mature. And so we evaluated both. And Substrate was just fell into our bucket in the sense that like our tech stack is Rust. Our entire tech stack is Rust. So, like that was a good, huge plus. We also got access to a lot of, so it has got a very good runtime palette system, for example, which we can configure and change. We also get access to, using grandpa and babe. I think it's a very underrated consensus mechanism. We also get NPOS, nominated proof of stake, from using Substrate, and this is like again very underappreciated in general, because it allows nominated proof of stake allows for wider stake distribution. So if you really want to build like a decentralized network, right, like where we had this problem actually in Polygon POS, right? Like, so even if you see today on the staking dashboard for Polygon POS, which uses Tendermint, like 8 to 10 or 12 validators control more than 67% of the stake. And we did a lot of things out of protocol to kind of change that distribution, right? Like, I mean, if you look at some of our staking dashboard UI things, right? Like we made changes so that people would delegate to the lower stake validators, for example, and so on, right? Like, and it's a very uphill task to get to that level of validator distribution. And so I thought this time around, we'll not get into that. Don't want to get into that problem, right? Like we want to aspire for a high validator set number, and we want stake to be distributed as large as possible. So these were some of the reasons, and of course substrate is very easy, it is pretty good to work with, got an active community, a lot of tooling around it, so it's easy to work with as well.
Nice. Interesting, the things you mentioned about the problem of the delegated proof of stake of tendermint chains. I fully agree on that. I was also, I worked for 1 year on Cosmos ecosystem, and that was something that was very problematic to me. The concentration of power in a few numbers of validators in the Cosmos chains is a big issue. I agree. Okay, thank you for this. Anurag, Apoorv, you want to tackle it also about substrate and the experience of working with it?
Yeah, sure. So like obviously for Madara, it's actually a little interesting as well. So obviously some of the points repeated as what Anurag just mentioned, right? Like the stack is Rust based, it is very modular, and it allows like more flexible changes in the consensus layer, like you were talking about. So that's I think probably like at the end of this, I'll say like even Abdel can comment better because he was involved, even like he was like these guys were involved in the starting. I joined sometime later, but yeah, like the experience right now is like basically it's very modular and Rust based, and obviously the palette structure is pretty good because like you can choose exactly what components you want. Right now by default we use like Grandpa, Aura, and we have our own palette, like the StarkNet palette. Like I think Avail has a data availability palette similarly, so we have our own palette which gives you the ability to execute Cairo smart contracts, which is basically the most important tech of Madara based chains. So that is very well. But other important really good things that we get from Substrate is so firstly, like what happens is a lot of the L2 stacks today are like they're just open source versions of the current L2 chain, which is also good. But the thing is that when those L2 chains were being built, you have to like cut edges so that you're also safe and you can get to market fast. And then over there, you somewhere sort of kill modularity, and you'll also see this with like tweets and people talking about it. But there are some like good stacks which are available, but they're not as modular as you think. And when we wanted to do that with like Madara, we wanted to have something that's like very modular. But building something modular is also risky. So like Substrate like fit in the perfect bucket there, where it has modularity, like more than like 150 chains, I think, like parachains exist today, like across Karnot and Kusama, which are all different in their own way, right? People are doing like different consensus, like they're also building solo chains. So they're like different consensus algorithms with different palettes, and there's a lot of modularity already available. And it's barrel tested because it's securing billions of dollars. So Substrate like checked both the boxes for us over there. And in terms of the tooling, that is just another big plus, right? So like building smart contracts is one thing, like you need tooling for that. But then when you're building chains, you need a separate set of tooling. Like how do I like, for example, like like StarkNet has a lot of smart contract tooling, but when you need like with Substrate, you need easy ways to like check your extrinsics. You need easy way to check what are the palettes and what are the functions they have, tools for benchmarking and so on. So all those things also came like pretty well with the Substrate. So those were the up points. But I would also mention that we recently decided to fork Substrate to make it even better for Madara. So this is actually a good place to clear the confusion. So like I think like not a lot of people know right now that we have forked Substrate, but the idea is that we're still on the latest version of the Karnot SDK. I forgot the number, 1.3 point something, I guess. But we essentially, the reason we forked it was because right now the WASM overhead which Substrate has, which is obviously like very good, and the WASM overhead obviously like allows the forkless upgrades and the deterministic execution, which is very good. But in the case of like the two things, like deterministic and forkless upgrades, in the case of Madara chains right now, we have the deterministic part which comes from the Cairo VM. So like we have offloaded the deterministic execution over there. And the second part, which is forkless upgrades, for now, because right now, like what we see a lot of app chains, like I said, right, like I think of this a lot of like startups, and that's how multiple like chains launch. They launch in a centralized way, and then eventually decide to decentralize. So the WASM upgrade thing, while it's good, right now it was just slowing our execution. And also we had like because we are using some of the public libraries like the Blockifier, the Cairo VM, which don't support WASM execution out of the box, so we need to fork them and then use them. So right now, to like get those things easier, we have forked Substrate to remove that enforcements which like enforce you to use WASM. So now we can use standard libraries in our runtime in Substrate. So basically, yeah, like those are the advantages of Substrate. Then we forked it and added a few more things to make it even more powerful for us.
Thank you very much. Okay, very cool. Now I would like to talk a bit about how Avail compared to other DA solutions like Celestia, Near maybe. So I'm thinking about few dimensions where we can compare them. One of them is the underlying technique to guarantee the data availability and how you do data availability sampling, etc. Another one could be the duration where the data are kept on the chain and so on. And if you have also other criteria to compare them, feel free to explain. But yeah, I think that's interesting for people to understand how Avail compared to Celestia on those aspects.
Yeah, for sure. So I think the best way to kind of like understand how we came about Avail's design choices is we use something called KZG polynomial commitments and validity proofs, whereas like Celestia uses like a more Merkle based commitment structure with optimistic, like with fraud proofs, for example, for data availability proofing, right? Like, so that's the main crux in by which, like, the technology which differentiates it. Like, Avail is probably a good way to think about Avail is like it's kind of like what Ethereum wants to do on its danksharding roadmap. They also plan to do implement data availability sampling with KZG polynomial commitments and like validity proofs. And so we differ from Ethereum's architecture in the sense that we don't do the sharding design decision, right? Like, so we just have like one single block where we kind of aggregate all the data from the rollups. But the beauty of our design is that this block size can grow as we want, right? Like, so internally we have benchmark sizes of up to 128 MB per block, right? Like, and that's actually pretty huge in terms of from the demand that is there at the moment, right? Like, so essentially one of the technical differences is the implementation itself. Like, I mean, very short, Celestia uses a more fraud-proof way based of doing data availability verification, and so we do a more validity-proof KZG polynomial commitment sort of verification, and it's like you can compare this to the difference between, let's say, optimistic rollups and ZK rollups, where like ZK rollups, as soon as the proof is generated and verified, like you have finality, like verification guarantees, for example. But in most optimistic constructions, you have like a delay delay period for the fraud proof challenge window. Similarly, Celestia also has a fraud-proof challenge window for the DA blocks for data availability to be finalized, for example. So that is like the technological differences. Of course, a lot of other
I have a question related to KZG. First question, so did you do your own trusted setup or did you leverage the one on Ethereum? That's the first question. And the other thing is not a question, but a comment. I think it's interesting for you guys because naturally, like rollups will use this KZG mechanism for Ethereum. So I think it will be probably easier for them to adapt and integrate with Avail, for example, for their layer 3s, etc., because it's the same mechanism, and they will have the proof of equivalence of their. Because, for example, for us, StarkWare, we don't use KZG, we use high-based commitments, but we do an equivalence basically with an interpolation on the polynomials and so on. And it means that we could use the same mechanism to integrate with Avail for StarkNet layer 3s. So I think that can be an advantage for Avail on this front. Yeah.
No, for sure. In general, like so we do not do our own trusted setup right now. We basically reused Filecoin's power of tau for now. We might do a separate.
You should move to the Ethereum one, I think. It might be even more strategic for you, I guess.
Exactly. So I mean, so that's the one on the current one, but like we can change the SRS pretty quickly. in general. But yeah, the idea is not to do our own trusted setup. We'll just reuse like what has been done already for Ethereum and so on.
What I will do if I were you, I will try to even comply with Ethereum SDK to submit blobs with 4844 so that people can like swap and replace very easily, almost transparently. Maybe it's on your plans, but I will do that, I think. Yeah.
No, certainly. It's on our roadmap, like to-do list, to add a wrapper SDK that mimics Ethereum.
That makes sense. Yeah.
Interfaces. So yeah, that will certainly be there.
Okay.
In general, I also want to touch upon a little bit of the other differences. Like for example, like the light client network that we built, right? Like I mean, actually, that's been one of our main focuses, right? Like so there. Actually, like if you just look at the base DA layer, right? Like I mean, if you look at, let's say, even Avail, right? Like it's a substrate chain with, let's say, 1,000 validators. Like Celestia is a Tendermint chain with 100 validators, for example. Ethereum has a more comprehensive consensus with like more than 100,000 validators and such, right? Like the main differentiator from a data development perspective is the data availability sampling thing, and there is a lot of low level work that we've done, especially on the libp2p stuff, for example, right? Like so initially we started using IPFS's libp2p library, but actually we then discarded it and we did a full refactor to go even deeper, like lower down the stack. And so we directly started using Kademlia DHT, for example, and so on. And so we are also contributing a little bit to the libp2p project, for example. So that, because that's very relevant if you want to have something like 1 million light clients running, for example, right? Like you need to solve a lot of low level P2P issues as well. Another thing is, as I already mentioned, right, like we want to be as decentralized as possible, and like with the issues of like deep delegated proof of stake system, right, like where 10 or 15 validators end up controlling 67% of the stake, right? Like we don't want that to be the case. We want a very decentralized set with as much high Nakamoto coefficient as possible. So those are some of the differences.
I also actually have a question here, like maybe for like both of you, because like on the same lines that you mentioned, right? Like Celestia has 100 nodes for Tendermint, and you guys can support 1,000. So like, how do you actually measure at like how much decentralization is enough? Because like the answer are also obviously different for rollups or like for nodes. And I remember like I think there was this talk where Gavin Wood said, like it also makes sense that at one point in time, like just adding more nodes is just marginal extra like advantage. Like how do you internally like measure, like this amount of decentralization is it's good enough. Like after this, we're just maybe spending too much time on the wrong side.
No, actually, it's a good question. Actually, in general, I think that's the same question. Like even the Ethereum researchers are like grappling with, because initially, if you look at the Ethereum design, right, like so the design was optimized for like a huge number of validators, and the staking cap was kept at like a 32 ETH, for example, right? Like, and recently there have been plans to kind of increase that cap of staking to, I think it's 2048 ETH, for example. I don't remember the exact figure. But the motivation for that is basically because right now what is happening is, like, even if right now the Ethereum consensus supports a high number of validators, it's basically a lot of validators pooling a lot of ETH in blocks of 32 ETH and running on the same validator machine, for example. So you have a situation where there are hundreds of or maybe thousands of entities, same entity running like the same validator nodes, right? Like so on paper you have like a lot of nodes, but it's like controlled by few entities, right? Like so that's why it the thing is that leads to a problem on the P2P layer, right? Like because there's a lot of traffic that has to be coordinated to kind of get attestations and such, for example. And so there's an active proposal within the Ethereum community as well to kind of increase the staking cap higher, so that like validators who kind of right now club their ETH in blocks of 32 ETH can now kind of put a higher amount and so thereby reduce the numbers. And so I think the Ethereum community is also thinking of reducing the validator set requirements. So I think the answer there is somewhere in between, right? Like, I mean, I don't think it's at 100. I don't think it's at like 1,000,000, for example, right? Like it's somewhere in between. And so that's why, like consensus mechanisms like the Gasper on Ethereum, for example, which has this hybrid ledger where there is this finality gadget on top, right? Like and like you have this sort of commit sync committee, for example, which kind of attached to a particular block, for example. So you have to have some trade-off between the number of validators, the amount of traffic that you want to coordinate for validator communication, and so on.
Yeah, exactly, and it puts pressure also on full nodes actually, because to verify the stations and so on. So indeed, if you have a validator set that is too big, it increases the requirements for the full nodes, and it hurts the decentralization of the full nodes. So yes, indeed, it's tricky. I agree. Also, I think I'm wondering, but I think it makes sense to use ground point babe, because I think that liveness is more important than instant finality for data availability layer actually. So I think
I think even
sense.
in like when they're like I think one of the cool things about that those like new DLLs coming out is that like we will see a lot of sovereign chains eventually, and even I think like having like liveness would be very important over there, because like the DA part is the only sort of like attestation that you're doing at that point in time, and without that it should be I mean technically you could still operate, but I think like at least like if the base DLL is not live at that point in time, then your sovereign chain is just running with not attesting anything anywhere.
Yeah, and to answer myself the question about the decentralization, it's a very good one. It seems that it's clear that we will go towards a world where the block production is not that decentralized, but as long as it's easy to verify, it's fine, it's acceptable, and as long as you have mechanism also to protect from censorship and so on. Like for example, if we increase the cap for validators, there should be still a way for small stakers to do some actions if there is censorship and so on, like forced inclusion or stuff like that. But I think that, for example, for StarkNet, we'll aim for a number probably between 100 and 1,000 block producers in the future once the network is decentralized. Okay, very cool. Can you guys talk about Avail incentivized testnet and the challenges, and also the collaboration between Karnot and Avail on that?
Yeah, for sure. I mean, we have been running the final incentivized testnet before the mainnet goes live for Avail in like maybe end of Q1 or early Q2 this year. And so we've been like working with your team since quite some time on like integrating Madara with Avail, for example. And so we wanted to take this opportunity when like Apoorv started Karnot, like how can we kind of take like Madara chains, app chains, and then ask people to run them. It's like a great test of what Madara can accomplish in general and at what scale, right? Like, and so we certainly see a future where there are going to be like thousands of these of Madara StarkWare rollups running, right? Like, because quite frankly, app chains are like are very relevant for scaling, right? Like, not every chain needs to be general purpose, right? Like, you need some chains to be like, a lot of the chains we anticipate in the future are going to be very app specific, because that's how actually even apps on the internet work, right? Like, I mean, there are a few big corporates who will have like these big general purpose sort of applications, but like there'll be a lot of companies or startups, for example, who will do some small experiments and then like iterate and then get to where they are, for example. And so this like so that I really think app change will do that, and like in general this is the first start of what will come once like Madara app change release on mainnet as well, right? Like so this is like a sneak preview. So this was an excellent opportunity to test that, and we are also very pleased to see the response. I hope like we are not giving Apoorv too many sleepless nights.
No, it was definitely. I mean, like getting the opportunity to collab with the Avail team was really a good thing for us and a great opportunity. And I think like we started discussing this I think mid-December, and that was like very close to when we launched as well. So like immediately, I think after that is when we built the CLI tool and got some few things done for the campaign. And like since then, like the response has been like very good. Like I think we're getting like the process to get listed on for your list your app chain is like you have to create a PR, and I think we're getting like 500 to 1,000 PRs every day. So it's like we have to be like it's been like so initially the process was like manually review, but then we like automated the entire thing. So there's like a GitHub workflow that merges everything. But right now they're like I think 800. Like I think we were just talking in the Madara group today, and they're like 800, 900 Madara app chains running right now, which is like the response has been really good.
Yeah, I saw some app chains with 200,000 transactions on
yeah. It's like really impressive, and obviously it's been a really good testing point for us as well, because while there have been like a lot of questions, but that's good, right? So we are getting to understand what the pain points of people are, what are the things that they don't understand, and in fact, like as a result of this, we have started revamping our docs. So I'm actually working on revamping the docs as well, which we should have very soon. So it should make further things like this, and even people running the Avail campaign right now, these docs should ideally make it very easier for people to get started. Apart from that, there are obviously some bugs and everything which are also fixing, which we found out thanks to this campaign. But yeah, completely agree with what Anurag mentioned. Is like building app changes. Like we don't see in Web 2, like the companies don't have like 10 companies don't have the same machine, right? They choose what tech stack you want, they choose where they want to host it. So we will see similar analogies with Web3 now. Like people will choose whether they want to use the Madara stack, some other stack, whether they want to use Avail as the DLL, some Ethereum or something else. That's going to happen, and people will do it based on their specific needs. And I think this specific partnership is going to be interesting to see those opportunities, like see what people are experimenting, and like where this direction is going.
Amazing. Yeah, and if you are listening and you consider running your app chain project, reach out to Apoorv, and Karnot can help you, because in 2 clicks you can launch your app chain and choose Avail as DA layer. So feel free to reach out to them, and also to participate to the campaign. It's good for Avail, it's good for Madara, it's good for everyone. It's good for you to also experiment cool innovation and cool tech. Anurag, can we talk a bit about the roadmap for Avail, the next steps, and also if you want to talk about maybe future collaborations between StarkNet and Avail, and yeah, that would be great.
Yeah, no, I think so. In general, like we've been publicly talking a little more about the Avail DA offering in general, but like we have been building a lot of stuff in the background. I also talked to you, Abdel, previously, right? That we are going to work very closely with StarkNet in the future. So I think basically, like I said in the beginning, right? Like we started Avail because we knew that like we are getting into this roll-up centric ecosystem, and this roll-ups are going to explode or proliferate from here on. And last year itself we saw like a lot of roll-ups. This year we are going to see like that increasing, and over the next few years it's going to be like roll-ups are going to be the main execution paradigm, right? Like, and so the first problem that we really started off was on how do we scale rollups in general, and we do it by the scalable DA solution that we started with, and which is going to mainnet pretty soon. But that's not it, right? Like so, in general, like once we've kind of enabled rollups to proliferate, and like there's going to be like hundreds and thousands of these rollups, right? Like now in this roll-up centric world, right? Like where if there are these thousands of rollups, I mean, just think what is going to happen to the user experience in that world, right? Like, I mean, if if a user has to kind of navigate like 10 different chains or 100 different chains with, you know, like assets lying in, you know, like different chains, for example. And so as it is right now, you have, you know, like people in Solana saying that, you know, like, okay, just deploy your apps to our chain, for example. You can deploy as many apps and the users have to connect to one chain only. But like, look at Ethereum, there are so many chains, you have to kind of bridge from one chain to another, for example. So there's a lot of cognitive overhead and especially user experience fragmentation. So I think, so the next layer of the problem that we really want to kind of focus on, we actually also have, you know, like a prototype of that ready, is basically how do we kind of build, unify rollups on Avail, using, you know, the combination of data availability sampling and proof aggregation in general. So that's why, you know, I mentioned to you, Abdel, that, you know, like we've been looking at, you know, like Cairo proof aggregation, for example, and also usage of storage proofs. We talked to Herodotus the other day on how we can leverage that, so that, you know, like we can make, like, even if we have like 500 Madara app chains, right, like it should be easy for users to kind of move or, you know, like call functionality from one chain to another, right? Like, and because it's ZK proven, right, like, and because we can aggregate these proofs across, you know, different Madara chains, for example. That's why you can actually enable this. And so you can do it this in, you know, like from a proof aggregation angle. But the whole purpose that we build this, the Avail DA layer from foundational principles, is because we wanted a very efficient data availability sampling or the verification. And if once we combine this DA verification and execution proof verification in one part, we are able to enable asynchronous composability on top, right? Like, so once we enable rollup scalability, the next goal is to enable, like, minimize UX fragmentation in the rollup ecosystem by enabling rollup interoperability. And rollup interoperability is a very different problem from, you know, like L1 to L1 interoperability, because rollups share a you know, like a base DA layer. And so that's why you can actually do this on top of, you know, like a shared DA layer, right? Like, so that's kind of the upcoming roadmap that we have, right? Like, in the sense that so we really want to become the coordination mechanism for, you know, like the Ethereum rollup centric future, is what we feel.
Very interesting. Okay, let's build it together.
Yeah, I mean, I was going to say something. So, like, we should build it together, because, like, when we were discussing the other day, like a sort of like a proof aggregation layer for interoperability will be like very much needed once we, like, this year when we're going to see like a lot of rollups. That will be like the next most important thing that we should be building. And this is also like one of the important reasons like why many of us chose like to go to a ZK solution, right? Because it's going to start making sense now. But yeah,
Exactly.
let's
Yeah.
build it together.
Amazing. I think that's a pretty cool conclusion, actually. I think we can wrap it up. So if you want to say a final word about, if you want to say something to the audience, feel free, both of you guys. It was super exciting, and was very happy to host you.
Yeah, I mean, firstly, thanks a lot for having me up there. And I would just like to say, like, if anyone's here listening right now and you're interested in either contributing to Madara or building an app chain with Madara, and obviously using Avail or any other layer as a DLR, then feel free to reach out to us, and like we would love to help in any other way. And looking forward to like more talks and more sessions like these. It's a really good place, you know, like talk to what other people are building and find out what's going on.
No,
Cool.
absolutely.
Thanks.
Yeah, thanks, Abdul, for inviting me here. In general, like, I think closing message, I just wanted to say this. In general, was that, like, I think there are a lot of high quality teams within the Ethereum ecosystem that are building various stuff, right? Like, but sometimes we tend to forget that, you know, like everyone is working to kind of solve the overall problem, right? Like, and we get into these fights and so on, right? Like, and especially
Yes.
Abdel, like you had this unaligned sort of this thing kind of, right? So I just want to kind of to say that, like the collaboration between Avail and StarkWare, like it's basically like, of course we are doing some specific sort of integration and so on, right? Like, but the bigger goal is to kind of like scale blockchains and like scale trustlessness, and like we really think that like that ZK technology, especially like, of course, I was I was founder of Polygon, and we built one of the first ZK EVMs. But even from that perspective, I will say that like the ZK EVM is a great step, but like it is very imperative to kind of try out different execution systems, because like if you just kind of like, of course the ZK EVMs are great, they solve a separate purpose, but unless we experiment with different execution environments, we'll not be able to unlock different kinds of applications. And if we don't make it easy to spin up these app chains, for example, we'll not be able to lower the friction by which new developers come into the system. So in general, like collaboration is very important for like to move the space forward. So I just want to end it there.
I could not agree more. That's a beautiful and inspiring message. So it's the perfect message to conclude this. So thank you very much. Bye bye.
Thank you.
Bye.
Bye.
Yep. Thank you, Apoorv.